Okay, so we're going to go ahead now and finish up 1.4. Now what we looked at right before break was we looked at triangles. Now we're going to move on to angles. And these again are much simpler than the investment problems and the distance problems. I think the angle problems are about the easiest as long as you remember that x is not your final answer, x is only part of the answer. So let's look at the different types. We have what are called vertical angles. And in vertical angles, they form an X, just like this. And the left equals the right. And the top angle equals the bottom angle. So when we look at a vertical angle, they're going to make an X. The top equals the bottom, left equals the right. We also have complementary angles. And these are also sometimes called right angles. And for complementary angles, they're going to sum to 90. Okay, so they sum to 90 degrees. So you've got the vertical angles that make an X. You've got the complementary angles that sum to 90. And then finally you have the supplementary angles that add up to be 180. And they make a straight line. And supplementary angles look like this, and they sum to 180 degrees. So those are the three types. Okay, we've got vertical angles, which they form an X, and the left equals the right, the top equals the bottom. Complementary angles, also known as right angles, they sum to 90. Supplementary angles sum to 180. We're going to do two of these, and then we're going to look at integers, and then that will finish up 1.4. So only a couple more questions to look at out of 1.4. We've already done the hard part out of 1.4. The second half of 1.4 is actually quite a bit easier. So I'm going to look at question 35 on page 100. And if you don't have your textbook with you, that's fine. I'm just going to draw the angle up on the screen here. So if you want to look it up in your textbook, you can. If you want to just watch the screen up here, you can do that as well. So what do we have? Well, we've got an angle, and we've got three different choices. They can equal each other, add together to give you 90, add together to give you 180. What do these form? They form an X, don't they? Mm-hmm. So since they form an X, what do we know? They're going to equal each other, because the top equals the bottom. So that tells us then that we've got 7x plus 17 equals 8x plus 2. Make sure I wrote it all down right. Yep, everything looks right here. Okay, so there's our equation. Now, when we solve it, is x going to be our answer? No. Nope, because we take it, plug it back in, and get the two angles. So let's go ahead and solve this by moving things around. We're going to move that 8x over, and we're going to move the 17 over also. So 7x minus 8x, that leaves you with a minus x. 17's are gone. 8x's are gone. Right? And we've got 2 minus 17. That makes it a minus 15. Divide by your negative 1. And now we've got x equaling now 15. But we are not done yet, because what do we have to do? Yep, take it, plug it back into both. Now they should be the same, so we're going to go ahead and plug it into both, and that's going to be our answer. So they should be equal to each other. So the first one is 7 times 15 plus 17. 7 times 15 is 105 plus 17 is 122 degrees. The other one should be the same. So what's the other one going to be? 8 times 15 plus 2. 8 times your 15, that's 120, plus 2 more also makes it what? 122 degrees, and these are the answers. And they should be equal, and they are. Again, students don't generally have trouble with these at all. These are good test questions. Where do students make a mistake at? They stop here. This is not our final answer. Plug it back in. But in terms of solving, much, much easier than any of the others. One more of these, and then we'll look at integers. How about question 38? This is a complementary angle problem. So this is going to be question 38. And 3x minus 9. And 6x here. So what do we know? Well, they make a right angle. So what do they sum to? 90 degrees. Right, so now we have 3x minus 9 plus 6x equals 90. Because this sums to 90 degrees. Now we can solve it. So 3x and 6x, add those together. That's 9x. Add your 9 over. Now we've got 9x equals now 99. And we'll divide by our 9. And that leaves us then with x equaling now 11. And if you want to, you can do it in separate steps. If you want to rewrite this as 9x minus 9 equals that 90 and then move it over, you can do that. I think we've done enough of them though now that I can probably skip that step and combine them together. So that gives us 11. Now 11 again is not our answer. So this 11, what do we have to do? Plug it back in. Plug in that 11, and that's going to be 3 times 11 minus 9. And that's going to be what, 24, I believe? Yep, 24 degrees on that one. And the other one is 6x, so that's 6 times 11. And that is then your 66 degrees. And we know that we did it correctly because these should sum up to give you 90, right? And they do. So those are the answers. So these questions are probably are more or less like a breath of fresh air compared to some of the others.
Yeah.
And same thing with consecutive integers. Students generally don't struggle so much with consecutive integers, which is the next part. Once we finished up completely 1-4, you're going to find 1-5, 1-6, and 1-7 to be a lot easier. They're inequalities and absolute values. And it's more algebra, it's not application. So this is the last part of the applications here. So let's now talk about consecutive integers. So when we talk about consecutive integers, we're talking about back-to-back numbers. So what would consecutive integers look like? Here's some examples. 3801, 3802, 3803, 3804. Those are examples of consecutive integers. Another one, how about 11, 12, 13, and 14? Those are also consecutive integers. They are back-to-back numbers. Now, what we know about the consecutive integers is the gap. Okay, the gap between these is always 1. So for consecutive integers, the gap is 1. So that means every time we're going to be adding 1. So for consecutive integers, we're going to call our first number x, second number x plus 1, third number x plus 2, and fourth number, if we need it, that's x plus 3. So when we talk about consecutive integers, we're talking about back-to-back numbers, okay? And look at the gap between each of these numbers. How do I get from one number to the next? I add 1 every time, right? So when we look at our pattern, what we do is we call the first number x, second number x plus 1, third number if we need it is x plus 2, and fourth number if we need it would be x plus 3. You can continue the pattern if you need more, but we never need, in this course, more than 4 of them. So consecutive integers have a gap of 1. Now what about even or odd? Well, they have a different gap. So even or odd consecutive integers. Well, what do they look like? Okay, these are like addresses. $36.19, $36.21, $36.23. Those are odd numbers, right? Addresses. You can also just have pages in the textbook. So you could have 12. What's the next even number in this case? 14. Next even number would be what? 16. Now, what's the difference between these and just plain consecutive integers? Well, these have a gap of what?
Plus 2.
2. Okay? So even or odd integers, consecutive integers have a gap of 2. So for these, the gap is going to be 2. So for consecutive even or odd, we have a gap of 2. So that means my first number would be x again, because that's what you start with. And then instead of adding 1, we're going to have to add 2. So then we have x plus 2. Add 2 more, that's x plus 4. Add 2 more, that would be x plus 6. Okay. So when we read these questions, what we do is we identify first, is it a plain consecutive integer question, or is it even or odd? If it's even or odd, we add 2 every time. If it's just plain consecutive integers, what do? We add 1 every time. Okay, so it's either 2 or it's 1. And you probably have seen this before in terms of algebra in your other classes, because you looked at consecutive even and odd integers and also just consecutive integers. Now, what I like to do is I like to come up with our equation in terms of words, and then I fill it in with the variables. Sometimes students get confused as far as the wording goes on these, but they're much, much simpler than any of the others. How about we look at question 42? So we're going to look here at question 42. Move it so we can see it here. First off, we're going to read it through, then we're going to figure out what we're working with, write up our equation, and solve it. Find 3 consecutive integers such that the sum of the first and twice the third is 39 more than twice the second. So what do we know first off? How many integers do we have? 3. Are they even or odd? No, they are just plain consecutive integers. So when we look at this question, we know we need 3 of them, and they are just plain consecutive integers. So that means we've got the first one, which is x, the second one, which is x plus 1, and the third one, which is x plus 2. Is everyone okay with that? So the first thing I did was I read it, and it said 3 consecutive integers. There they are. Now we're going to try to build our equation. So let's see what we've got. Okay, find 3 consecutive integers, that's this part, such that the sum of the first and twice the third. Okay, the first number, we'll just use a 1 there. Don't put the variables x in yet, because I think it'll be confusing if you start putting the variables in. So we're going to write it out with the numbers, and then we'll plug the variables in, such that the sum of the first and twice the third. So that means plus 2 times our third number is, again, that means equals 39 more than twice the second. So that's 39 plus 2 times the second number. Let's make sure we see where all this came from. Sum of the first and twice the third. So there's that piece. That means equals 39 more, okay, 39 plus twice the second. So we put the 2 in front, and there's our second number. Now we've got it. Now we can build our equation. Okay, so now we've got it. Now we're going to use this to build our equation. We plug in our values for what they are, solve it out, and then we'll get all 3 of the numbers. So the first piece is number 1. So number 1 corresponds to x. And then we've got 3, so we have 2 out in front, and the 3 is x plus 2. That gets plugged in there, equals then 39 plus 2 times the second number, which is x plus 1, which is there. Is everyone okay with that so far? Now we just solve it, and we'll be able to finish it. So distribute your 2's through. And that gives me now x plus 2x plus 4 equals 39 plus 2x plus 2. Now we just combine, so I'm going to clean it up first. So let's work on the left-hand side, combining like terms. That's 3x plus 4. On the right-hand side, we've got 2x, and then 39 and 2 more makes it 41. And move things around, so move the 2x over, and move the 4 over. So that leaves me then with an x on the left, and on the right we've got 41 minus 4. That should be a 37. That's your answer. Now, how do we write it so it's correct? We want what? We want all three of the numbers. So what would all three of the numbers be? 37, add one more makes it 38, and add one more makes it 39. So these are the actual answers. You've got all three of them. Is everyone okay with that? It's pretty easy if you just write down your equation like I did here, then plug in your values and solve it. Much, much simpler. If you just try to get and jump to this first, you'll make a mistake. So it's going to be a lot easier if you write it out in terms of the number signs like I've got here, plug the values in, and finish it. Let's look now at one that has an even or an odd integer in it. 49. Okay, question 49. This one works with, in this case, the odd integers. And we also have to watch the terminology when it talks about the middle, the greatest, and the least integer. So question 49. Find three consecutive odd integers such that the sum of the least integer and the middle integer is 19 more than the greatest integer. So think about what we've got. Find three consecutive odd integers. So what does that tell me? We need three of them. And what's our gap?
2.
2. So the first one is always x. Second one, x plus 2, because these are odd. Right, so those are odd there. Okay, what about the next one? That's going to be
X plus 4.
Yep, x plus 4. So those are our three consecutive odd integers there. Now what we're going to do next is we're going to build our equation. And we need to remember what's the middle, the least, and the greatest integer, how they're labeled. When I look at this one's going to be the least because it's the smallest. This is the middle. And this is the greatest integer. So the least integer is going to be the first one because that's your smallest number. You assume these are positive. So they're, in this case, going to be positive. We assume they're positive. So the smaller number that is going to be the first one. Add 2 more, get the middle. Add 4 more, get the final one. And what do we need to know? Well, let's go back to our question. Find 3 consecutive odd integers. That's this piece right here. Such that the sum of the least and the middle. Okay? Least in the middle. What would that be? Least is going to be number 1. Middle is going to be number 2. Okay, so least in the middle is, that is means equals, 19 more than the greatest. So that's 19 plus the third number. Is everyone okay with how I got them? Let's take a moment to make sure. We want 3 consecutive odd integers. Here they are. Such that the sum of the least integer, that's this one, and the middle integer, that's this one, is, means equals, 19 more, there's your 19, and the greatest integer. So that's going to be 19 plus your 3. Now we can fill it in. So that's going to be x there. This one is x plus 2. And we've got 19 plus our third one, which is x plus 4. Clean it up, solve it, and we'll get our 3 integers. Let's add these together. That gives me 2x plus 2 on the left. On the right, we've got x plus, adding them together, looks like 23. Move things around. So move that x over. Move that 2 over. And we now have x equals 21, isn't it? Okay, and what are our 3 answers going to be? Yep, 21, add 2 more. 23, add 2 more. 25. Those are my 3 answers. So that's how you work that one out. There's one more I want to set up here for us. Now, just to make sure we know how to set these up, I'm going to set up one of them. I'm not going to work it out completely. I'm going to set up one of these from your homework. And let's look at, now they're all pretty easy. Let's look at number 18 from your homework. Well, actually, let's do 17 because it's got negatives in it. We'll do 17. The 17 has the negatives in it. I'm not going to solve, well, it may solve it out because that one's, there's not much to it, but they're all very similar. So now let's work through question 17 from your homework. And I'm picking this one because this is the one that has a negative number in it. And sometimes students work it all the way out, but then they get the wrong answer at the very end. Because this is what trips up students. Larger integer. Okay, so the sum of 2 consecutive integers is a negative 369. Very simple to set up. What do we know? 2 integers, okay? And they are not even or odd, so they are just consecutive integers. So that means a gap of 1. So we need 2 of them. So the first number is x, second number is x plus 1. And we know the first number plus the second number has to equal that negative 369. Okay. Very, very simple to do. Plug in our values, so that's x. Plug in this one, it's x plus 1. We're going to go ahead and combine the x's together. That makes it 2x. Move the 1 over, and that makes it a minus 370. Okay, we're going to divide by 2. And that leaves you now with 370 over 2, which is 185, and it's negative, isn't it? Okay, now, what are my 2 numbers? Let's find them first. My first number is negative 185. If I add 1 to it, that makes it a negative 181. 4. Right? Because you're adding 1. So my 2 numbers are negative 185 and negative 184, not negative 186, because you're adding 1 to a negative number. Now, what do we want? We want the larger number. Yep. And which one of these is really larger? Which one of these is closer to 0? Negative 184. So what would my answer be for the larger number? Negative 184, right? Because it's closer to 0. Make sure you're careful with those negatives there. A lot of times what happens is students get to this negative 185. They add 1. They say it's negative 186. And it's not. It's negative 184. And then they write down negative 186 as the large number. And that's not correct. So make sure you get them. When you add 1 to a negative, remember, it makes it larger, and then your larger number is the smaller negative number. So that now finishes up 1.4. Next, we're going to look at 1.5. And 1.5 you've seen before, and it's a much much easier section. It won't take long at all for us to go through 1-5. We might even get through 1-6 today as well, because there's not much to either one of these. 1.5 is inequalities. And we're going to be graphing these on a number line. So when we talk about greater than, less than, on the number line, those get parentheses. Greater than or equal to, less than or equal to, those get your square brackets. And positive infinity or negative infinity, they always get parentheses. Now, when we start solving these inequalities, one thing that we also need to remember, that we need to know, is when you divide by a negative. So when we start solving, when you divide by a negative, does anyone remember what happens to the inequality sign? Yep, when you divide by a negative, the inequality symbol flips. And so we need to remember that note there. So whenever you divide by negative, you flip that inequality. Let's just do 2 or 3 of these where we graph them. And we write our answer in interval notation, and then we'll do some where we solve them. So we're just going to go ahead and graph these and write in interval notation. So let's just try to graph a couple of these. And let's say x is less than a negative 4. So what I want to do is I want to graph this on the number line. So how I do it is I make sure my x is on the left, which it is. Okay, so x is on the left. And I look at which way it points. So which way does it point? Okay, it points to the left, so that's where we shade. So we want x is less than negative 4. So we come over to our number line. And just on the number line somewhere you put in your negative 4. And which way is it pointing? It's pointing to the left, so we shade to the left. And brackets or parentheses here? Parentheses. Yep, this one's going to get parentheses. And where does it go to? Negative infinity. And what would that look like in interval notation? Well, interval notation, that's negative infinity with parentheses, comma, negative 4 also with what? Parentheses. And they come directly from the number line in the same order. So always graph it first, and then use that graph to get the interval notation. Okay, let's do another one. Let's say x is, how about greater than or equal to 12? How would we graph x is greater than or equal to 12? Well, draw a number line. We put the 12 here. And we look at which way it points. Which way is it pointing? It's pointing to the right. So where do we shade? We shade to the right. See, it's the easiest way to remember is just look at which way it points. If it points to the right, shade to the right. Points to the left, shade to the left. Now, what else do we know? Greater than or equal to, less than or equal to. Those get brackets. So this gets bracket. And where does it go to? Positive infinity on the right. Okay, so what does it get? In interval notation, square bracket, 12. And when we talk about this parentheses, does it get brackets or parentheses?
Parentheses.
Parentheses on that infinity symbol. Why? because the infinity symbol always gets parentheses. One more, and then we'll start solving. Let's do a double inequality, a three-part inequality. How do we graph this one? Well, this one is a three-part inequality. So we look at it, and is it in the correct order? Yep, -5 is a smaller number. It's on the left, +4 is on the right. So we just find our -5, +4, and -5 gets brackets. +4 gets parentheses. And so what's it look like in interval notation? From left to right, -5 with square bracket, comma 4 with what? With parentheses, right? Now we can solve these. We're going to be solving a lot of these inequalities. And all we have to remember is one extra step at the end, graph it. That's it. Whenever we divide or multiply by a negative, switch your inequality symbols. So now let's go ahead and solve and graph some of these. So we'll just start with a basic one here. We're going to try and solve and graph this one. What are we going to do? Well, we're going to move that 3 over. So 3x goes over. And then we're going to add the 5. And we've got 8x minus 3x. Well, that leaves you then with a 5x. Inequality symbol stays the same. And 15 plus 5 is a 20. Divide by our 5. Do we flip the inequality symbol? Yes or no? No. Why not? We divided by what? +5. When do we switch the symbol? When we divide by a negative. So it stays the same. Nothing changes. And 20 divided by 5 is a 4. Finish it up. Use the number line here. Here's our 4. Which way does it point? It points to the left, so we shade to the left. Brackets or parentheses? Square brackets, right? Because that's got the less than or equal to there, so it gets square brackets, and it goes to negative infinity on the left. What's our answer look like now in interval notation? Parentheses negative infinity, comma 4 with a square bracket. Okay, there's your answer now in interval notation. Let's do one where we have to switch the inequality, and then we'll look at some fractions. So let's do a couple of these where we have to switch the inequality symbol. We'll look at some fractions, and there are a couple of applications, but we're just going to go over them from your homework. So we'll do a couple more of these. We'll look at a couple of questions from your homework on how to set them up. And that will be it for 1-5. Okay, so let's go ahead now and solve and graph. And how about we do a three-part inequality? How about minus 8x plus 3 in the middle? And let's use a negative 9 on the left and positive 10 on the right. Okay, so we're going to go ahead now and solve and graph this one. So this one is going to make us flip the inequality symbol. We haven't done the 3-part yet, but what do we do for the 3-part? Well, we try to get the x in the middle by itself. So that means to get it in the middle, what do we need to do? We need to move the 3 over with subtraction. Minus 9 minus 3, that makes it a minus 12. And 10 minus 3, that makes it a positive 7. Nothing new at all there. Just move it over. And don't forget your x is negative. Now, what are we going to do next? We're going to divide by what? Negative 8. Now, when we divide by a negative, what is that going to do to your inequalities? Okay, so they flip around. So since we divided by a negative, that means this one flips. And so does this one. Negative 12 divided by negative 8. Negative and negative makes it positive. Okay, and 12 divided by 8, you can either use a fraction, or probably want to keep it a fraction. You can use a decimal, but I would just keep it as a fraction. Okay, 12 divided by 8 is not going to go in there evenly. So we could reduce that down to be 3/4. Or, sorry, 3/2. Okay. You can use a decimal if you want. I prefer a fraction. And what about 7/8? 7/8 is not going to reduce at all. I'll just bring the negative up to the top. Okay. But you could have also wrote 1.5 here. I prefer a fraction. And that's generally what you want as a fraction, not a decimal, unless it already has decimals in it. Now, when we go to graph this, we have to be very, very careful. We flipped our inequality symbols, right? So that means the order in which they go on the number line also has to flip. Because here's going to be our 0. And negative 7/8, well, negative 7/8 is back here. And 3/2 is where? Over here. So see, they flipped around. Why do they flip around? Because you flipped the inequality. And you have to make sure that the negatives are on the left, positives are on the right. What do we do for this double inequality? Well, we shade in the middle. Textbook calls them 3-part. I call them double inequality. And what do we have? At the negative 7/8, we've got what? We've got parentheses, don't we? Right? And at the 3/2, we've got square brackets. And so what does it look like in terms of interval notation? Well, in interval notation, it looks like negative 7/8 with the parentheses, comma, 3/2 with square bracket. So whenever you have to flip your inequality sign, make sure they are in the correct order in those 3-part or double inequalities. Okay, let's do a couple more, and then we'll look at the applications. And let's make that a negative right there. Make that a negative 8x plus 5 over 4. And then we've got less than or equal to 3x minus 1 over 2. Well, we're going to solve this. Now, we can clear the fractions the same way that we cleared fractions before. We can cross multiply. Nothing's going to change. We just simply cross multiply. So that gives you, when you cross multiply now, 2 times a minus 8x plus 5. Inequality symbol stays the same. On the right hand side we have 4 times 3x minus 1. So we didn't flip that inequality symbol. all we did was cross multiply. The only time we flip the inequality symbol is at the very, very end if we divide by a negative. Otherwise, it stays the same. So we just simply cross multiplied to clear our fractions. Now we'll distribute through. And that leaves you with a minus 16x. 2 times 5 is 10. Right-hand side, 4 times 3x is a 12x. 4 times minus 1 is a minus 4. Move things around. So move that 12x over. Move that 10 over. And we've got 16 and 12. That's a 28, I believe. That's going to be a negative 28x here. Inequality symbol stays the same for right now. Minus 4 minus 10, that makes it a minus 16. Or sorry, minus 14. My mistake there, not minus 16. Sorry about that. Should be minus 14 there. Now what can we do? We're going to divide. Now when we divide by negative 28, what happens? We have to flip our sign, don't we? Okay, so x is over here. We're going to flip our inequality symbol. And that's going to reduce quite a bit. Negative and negative makes it positive. And that's going to now reduce down to a half, isn't it? Yes. It's going to reduce down to a half because 14 and 28 are both multiples of 7. So that's going to reduce down to a positive 1/2 there. And if you did use 0.5, I would be okay with that. I would, though, prefer the fraction instead of the decimal. On a number line, we've got our 1/2. And which way does it point? Points to the right. So where do we shade? Shade to the right. It gets square brackets, goes to positive infinity. So what's it look like for our final answer? It looks like square bracket 1/2. And where does it go to? Infinity with parentheses. Okay. Is everyone all right with that so far? So the main takeaway with these is what? When you divide or multiply by a negative, what happens to that symbol? That symbol gets flipped around. Also, what else do we have to remember? Which way it points is the way that we shade. Okay, so we flipped our inequality here. So at the very last step, which way does it point? Points to the right. Which way do we shade? To the right. Let's look at one more, and then we'll set up the 2 applications from your homework. This one's another 3-part inequality. This one also has a fraction in it. And it's not going to be that difficult at all. It's going to be very, very easy to do. One fraction. Okay, what are we going to do? Well, we're going to clear out the fractions. And remember, these are all over what?
5.
Over 1. Yep, this is over 5 in the middle here. And these are over 1, aren't they?
Yeah.
How can we clear out the fractions?
Cross multiply.
Yep. And so all that gives you then, when you cross multiply, now 1 times anything, it just stays the same. So 1 times that 8x plus 3 is still what? 8x plus 3. What about the other side?
15 and 40.
Yep. And I should make that a negative 8. Sorry about that. That way it'll work out right. Make sure make that a negative 8 there. Because otherwise it won't graph right. Okay, so 5 times a negative 8, that makes it a what?
Negative 40.
Negative 40. 5 times 3 makes it a
Positive
positive 15. That's how you clear them out. You just simply multiply like that. Okay, negative 8 times 5 is negative 40. 5 times 3 is 15. Did we switch our inequality symbols?
Not yet.
Nope. Move that 3 over with subtraction. That makes it then a minus 43. 8x is in the middle. And it looks like a 12 is on the right. Wait a minute. Oh, yeah, well, let me make sure we got the right pieces here. That should be just greater. Sorry, less than. It's just less than there. Okay. So everything is right. We don't flip our inequality symbol. Why not? Because we're going to divide by what?
Positive.
Positive 8. So that means we don't have to switch our symbols. Negative 43 over 8 is not going to reduce down. X is still staying in the middle. 12 over 8 is going to reduce down, and that's going to reduce down to 3/2, isn't it? So they both have 4s in common. Okay, now what do? Graph it. Is it in the correct order? Yes, negatives on the left where it should be. So negative 43 over 8 is on the left. 3 over 2 is on the right. Negative 43 over 8 gets parentheses. 3/2 gets the square bracket, and we shade in the middle. And then we write our answer, interval notation. And that is parentheses minus 43 over 8, comma, 3 over 2 with parentheses there.
Can you explain one more time when you cross multiply
Okay.
at the very top?
Okay, at the very top, 5 times that negative 8, that makes it a negative 40, right?
Oh.
But this 1 down here, when I take 1 times that, it doesn't change it, does it?
No.
So we don't have to worry about it. And that's how they're all going to be. They won't give you any of the fractions. Okay, so that's going to be right here. So all we have to do is just 1 times that stays the same. And then over here we do the same thing. 5 times 3, that makes it then the 15. And 1 times that doesn't change it at all either, does it?
Okay.
So that's why you can work it out that way. Very, very similar to question 6 in your homework. You'll do the same thing. You're just going to multiply both sides by what? The 7, right? Yep, right, because it's a 7. Same thing though. Almost identical problem. It's just you'll multiply it by 7. Instead of in our case, we use the 5. But yeah, whenever there's a number below, you can just multiply like that and it'll get rid of it. Now let's set up a couple of these applications. So let's look at our homework. Uh, 1.5, and I'm going to set up question 8 for you. So we're going to look at 2 different job offers. And we want to come up with an inequality to help us make the best decision possible as to which job we should apply for and take. So the salesman has 2 different job offers. Company A offers a weekly salary of $280 plus 8% commission. Company B offers a salary of $560 plus only a 4% commission. What is the amount of sales above which Company A's offer is the better of the 2? Now, if we talk about being better of the 2, that means you're going to make more money. So what's our inequality look like? We want Company A to be the better job offer. So that means we want Company A to be greater than Company B. We want it to make more money, so it's going to be larger. Right? That's what we want. We want Company A to have the better offer than company B. So larger makes more money. Now, what do we know about company A? Well, company A, you get paid no matter what a flat rate of 280. So you get paid 280. Now, what about the commission? Okay, 8% commission, right? And as a decimal, that's 0.08. Now, we can't just leave that 0.08 there. We have to always attach something to the decimal, to the percentage rate. So we're going to use X, because X represents how much you made in sales. So whatever I make in sales, I make 8%. Now, if I don't make any sales, I get 280. So that's going to be my base pay. If I sell no cars, maybe I'm a car salesman. If I don't sell any cars, I'm guaranteed at least 280. The more I sell, the more money I make. Now, what about company B? Well, company B, it's a little bit less risky, because company B, you make $560 as a base salary plus 4% of the sales. Well, 4% would be 0.04. So that's going to be plus 0.04x then. And you can solve it and finish it from there. Because what this is going to tell us is how much we have to make every month in sales to make sure that if I take company A's offer, I make more money. Right? If I don't make much in sales, company B is going to be better. But if it comes out to be I have to make 10,000 in sales for it to be a better buy, then or better offer, then I have to make sure I do that every month. Or if I don't think I can do that, I want the other one. So all you have to do is finish it and solve it and graph it from there. I'm going to set up one more of these, and then you can do the other one. So I'm going to do a 10. You can do 9 on your own. So I'm going to set up question 10. You can try to work through 9. So John has 811 points in his math course. Now he has to have 74% of the 1,200 points possible by the end of the term to be able to pass and go on to the next course to get credit. What is the minimum number of additional points he must earn by the end of the term to receive credit? So let's think about what we've got. What do we have right now? Well, right now, we have currently 811 points, right? That's what we've got now. Now we want 74% of the 1,200 points. And what would that be? So that's 0.74 times your 1,200. And to make sure we get credit for this course, we need to make sure we get that 74. So 74% of the 1,200 total points possible is 888, right? Is everyone okay with that? So now what do we need? We need to make sure we get credit for the course. So how many points do we currently have? 811. We are going to get some more points. So there's more points possible. Maybe there's a couple of exams left. But we don't know how many points we need, so we're going to use an X. And we want to make sure we receive credit for this class, so it has to be greater than or equal to 888. And you can finish it from there. It's very simple to finish. And this is going to make sure that I pass the class, because I've got 811 points right now. I can earn some additional points. Maybe this is my final. How many points I need in the final? I want to make sure I pass, so I have to make sure I get that 888 points, because that's your 74. And now you can finish it. Right? So move that 811 over, and you're done. And that's going to tell you how many additional points you have to have. And we said it was greater than or equal to, because it can equal that 74, right? 74%, which is that 880. You can equal it or be bigger than. Let's now go ahead and take a short break. We're going to come back, and we're going to look at 1.6. So let's take a short break, and let's meet back here at, how about 10:55? So meet back here at 10:55, and we should be able to get through, hopefully, 1.6. Because there's not much to 1.6.